Lesson 7 in Unit 1. More limits. Okay? And now I will say, guys, we spend Unit 1 on limits, but once we get past Unit 1, I don't think I have another unit that is just limits. Because we spend a couple of units with derivatives and a couple of units with integrals. Okay, so brand new topics we have to learn. Okay, so in our first lesson on understanding limits, you were confronted with these two situations. We begin to compare and contrast, and that's talking about infinite limits and limits at infinity, which you've worked with a little bit. We're going to work with them more now. So we're going to compare and contrast behavior of functions as they approach infinity, as well as functions that tend towards infinity in certain circumstances. So we're going to use the graphs. Now, you kind of have to watch carefully here. The top graph is f of x. The bottom graph is g of x. And the questions are kind of mixed. So just kind of be aware here. Okay? We're going to use this to kind of look at, discover some information here. So let's go ahead and look here. The limit as f of x, or as x approaches 4 from the left on f of x. So what are we thinking there? The limit as x approaches 4 from the left of f of x is what? Positive infinity. What about the limit as x approaches 4 from the right? Negative infinity, because it goes down, right? I remember where I want to go here. Because she kind of jumped around. I was trying to remember how she jumped around the notes. But, okay. Let's go ahead and look at these other two now. Notice, what do these next two questions ask? G. So now we're using the bottom graph for these two questions. It confused me, I'll say, So the limit as x approaches 1 from the left on G. So down here, the limit as x approaches 1 from the left is what? Negative infinity. Limit as x approaches 1 from the right. Positive infinity. Okay. What's the graph characteristic that's happening here? Well, my limits are going to infinity and negative infinity, but what do we physically see on the graph? In both cases, what we just talked about there, it was a vertical asymptote, right? So the idea here that vertical asymptote, what's happening when we have vertical asymptotes? There are one-sided limits, and the idea is that these one-sided limits, she used the words unbounded. Okay, we can use the word unbounded, and that this limit is unbounded. It goes up infinitely. This limit is unbounded in the negative direction. It goes down infinitely. Same thing over here. These limits are unbounded in how they are going. And so vertical asymptote occurs if one-sided limits are unbounded. So in other words, if we know this information about the graph without having the graph in front of us, it can help us to connect that, oh, this one's going to positive, this one's going to negative infinity on opposite sides of 4. That means there's got to be a vertical asymptote happening there. Okay, those are some of the connections we can make. So in the discovery, a vertical asymptote occurs if one-sided limits are unbounded. A vertical asymptote occurs if one-sided limits are unbounded. So going to infinity and negative infinity are unbounded. And those are what we call infinite limits there. Okay. So as x approaches some number value, we generally say c there, as x approaches some number value, the limit was either going to positive infinity or negative infinity. thus a vertical asymptote. So I'm going to, let's see, as x approaches c, so think like limit there, the limit will approach positive infinity or negative infinity. And I'm going to put in parentheses, vertical asymptote. So infinite limit happens when as x approaches c, the limit approaches either positive infinity or negative infinity. Okay. Bottom half. Let's do the limits. So this one is limit as x approaches negative infinity on f of x. So as x approaches negative infinity on f of x, or up on the top graph, what's our y value going towards? Negative 2. As x approaches positive infinity on f of x, what's my graph going towards? The y value of negative 2, yes? Because there is a what at negative 2? Yeah, a horizontal asymptote this time, right? So top, we were looking at vertical asymptotes. If you get the drift, we're going to look at horizontals here.
Wait, can you trace that?
So as x approaches negative infinity.
Oh, I was looking at the wrong graph.
Okay. So yes, I can trace it in that right there. Are we good?
Yeah. Good.
Top graph. Everyone. I see it. Okay, so I don't think you were the only one guilty of that. Okay. Now I'm ready to look at the bottom graph. As x approaches negative infinity on g of x. So as we go off to the left, what y value are we approaching? Negative infinity, right. Okay, so it's a slant asymptote. We haven't dealt with slant asymptotes a whole lot, but we have a little bit, right? Slant asymptote, it's gradual, but it's going to keep going down and down and down, isn't it? Which means it is going to go down to negative infinity. What about as we approach x on the right, as we go off to positive infinity? Where's my graph going? It's going to keep going up, so positive infinity. So the idea here, excuse me, these were all as x approached positive or negative infinity, yes. And as x approached positive or negative infinity, we are looking at the horizontal asymptote. Okay, so the idea that as x approaches positive or negative infinity, the limit will approach a y value or will be unbounded. Either way, it's a horizontal type asymptote. Slant asymptote falls into the category of with horizontal asymptotes. So as x approaches, and I'm just going to say plus or minus infinity, the limit will approach a y value or will be unbounded. And again, this is referencing horizontal asymptotes. Okay. So I pretty much have the exact same thing written in the bottom. Did I do that on purpose or accident? I wonder if I put the wrong thing in Discovery. Oh well. Yeah, as x approaches positive negative infinity, the limit will approach some y value or will be unbounded. And again, we're referring to horizontal asymptotes. Also talks about slant asymptotes. Do I need to rewrite that? I put the same thing, but it makes me wonder. I don't know. I'll have to look at the answer key later and see.
I just wrote it.
Yeah. I have the same thing.
Ditto roots.
I would like to read it. I'm just.
Oops.
We just might get confused on our own.
For a second, I thought you were C as in like we
The
do.
C.
Ocean.
Yeah, that's
Oh.
what I thought too.
I promise, no. Well, that doesn't.
So Sergeant, that's looking like my handwriting now. Hold on.
That's getting bad, isn't it? Okay, moving on. In pre-calculus. Okay, here we go. In pre-calculus, you learn some basic truths about rational functions. When a factor canceled from the denominator, a blank occurred.
Asymptote. Yes.
Oh,
When a factor canceled,
I knew
I was right there with you, Meg. It's okay.
a whole occurred.
it. She did.
Watch the keyword here. When a factor canceled, a whole occurred. When a factor would not cancel from the denominator, a blank occurred.
Asymptote.
What type of asymptote?
Vertical.
There we go. Redemption. A vertical asymptote occurred. Okay. So, basic information there. Still kind of reviewing that. That's pre-calc stuff you learned. Really even learned it back in Algebra 2 that we still use a lot now. Calc. Okay, so we're going to use some of that information here a little bit and just in general working with these limits more. So let's look at the limit as x approaches 4 from the left. If we put 4 in as is, guess what's going to happen? We're probably going to have a 0 over 0 is my guess. Okay. Or maybe something, but I don't know. So, what are you guessing we could probably be able to do here? Could we probably factor? Now, first thing I would do is one on top, one on factoring. Yeah, I would factor a negative out front. So, right up here, I'm just going to show that if I factor a negative out front, it's now 2x squared plus, oh, wait. I agree with negative.
Negative 2.
Negative 2. I said that, I realized it as I was writing down. I'm like, wait, 2, 2, 12. Oh, wait. No, pull out negative 2, yes? Okay. So we're going to factor out a negative 2, which then leaves us with positive x squared plus x minus 6. I don't know about you guys, but that looks a lot nicer, doesn't it? Now, limit as x approaches 4 from the left. If we keep factoring, can we keep factoring? On top, if I put the negative 2 out front, then x squared plus x minus 6 will factor into x plus 3, x minus 2. See, I'm not holding your hands here. You gotta know it. On bottom, we could factor it into x minus 2, x minus 4. Good news is, well, we did all that factoring and there was a cause for doing that factoring because we do have canceling. So as we explore this limit now, it's a limit as x approaches 4 from the left of negative 2 times x plus 3 over x minus 4. Are you seeing that? If we plug 4 in, we're still going to get 0 in the denominator, yes? Well, officially, this particular limit is as we approach 4 from the left. If we plug something like 3.999 in, I use 3.99. You know, however many nines you want there. So if we try this, let's see. I'm going to have negative 2 times 3.99 plus 3 divided by 3.99 minus 4. So on top, it's negative 2 times 6.99. On bottom, it's negative 0.01. Well, first of all, it's a negative divided by a negative, which is a positive, yes? So whatever kind of answer I give, I'm going to give positive. Now, this currently is approximately 14, right? 14-ish, divided by 0.01. What's going to happen? Yeah, negatives are going to cancel out. Okay, so what's your calculator say? If you do 14 divided by 0.01. It's going to get bigger, right? And this is a concept we have to understand. So if you do 14 divided by 0.01, I'm leaving the negatives off, so we already discussed it's going to be a positive answer. You're at what? 1,400? Is that my right guess?
Yeah.
Okay. So what if this was 6.99? Wait, 6.999 and 0.001? Now we're at 14,000. What if we add another 9? In other words, what if we add another decimal place? Are you seeing where we're going? We're going to positive infinity here, aren't we? Okay, we are going to positive infinity. Okay, that's where we're going. That's where you've got it. That's my proof to you when I'm saying, you know, in the past, oh, we can't divide by 0. We can't divide by 0. But this is a limit. So are we technically dividing by 0? No, we are dividing by something very, 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 very close to 0. And the closer you get to 0, the bigger it pushes that top number. It, as you said, it gets bigger, right? It adds more decimal places. So this is going to positive infinity. And so that's kind of like one of the things I'm trying to get you guys to grasp is when you have a 0 in the bottom, but not the top, we're usually tending towards infinity. Or negative infinity, depending on the sign situation. Okay? So this is us rationalizing it, you know. Now, if this is just as x approaches 4, then we have to examine the left and the right. In this case, because it's just one side, we don't have to, you know, we don't have to look at both. Okay? No. That just, and what that tells me is there is a hole there, but we're looking at the limit as x approaches 4. So by canceling out the x minus 2, it made my math a little bit easier. Because I don't know about you guys, but I wouldn't have been wanting to try and plug 3.99 in here. That, you know, that gets a lot more complicated. Okay? And as much as I know we're not using calculators right now, it doesn't hurt to play around to try and experiment with, okay, what's really going on there. Okay, B, first of all, notice it is the same equation. Did you catch that? Or not yet? Pretty sure it is, isn't it? Yeah, it's the same equation. So I'm going to cheat off myself. Okay, I'm down to the factored version with instantaneously. Now this time, it's as we approach 4 from the right. So as we approach 4 from the right, what happens here? And again, can you plug in, you know, start with something like 4.01 if you want. This time, what is the main difference? I mean, it's -2 times 7.01, so numerically it's still about 2 times 7 or about 14. On bottom, it's 0.01, but what's the difference? Yeah, we now have a negative divided by a positive instead of just having the same signs. So this one is going to result in what? Negative infinity. Now, does that make sense? X minus 4 is the denominator, yes? It doesn't cancel. So what is x minus 4? A vertical asymptote. Does it make sense that one side's positive and one side's negative? Yeah. Question?
Don't worry about it. I was gonna ask if you could go through how you factored that as a joke.
And here's what I'm going to say. There.
C above. Actually,
C to the left. How's that? That's my answer. C to the left. Okay. I think we actually have to factor these, don't we? Where am I at on time? Okay. Let's get this factored real quick. See if we can get through this and be at a good stopping point. X squared minus 2x plus 5. Some of you have realized it doesn't actually factor. I'm having issues. I'm struggling.
I just looked at it and I was like,
I started writing it out and I'm like, wait, you can't multiply. Oh, man. Okay.
the bottom factors.
The bottom factors. Yeah, I agree with the bottom factors, but anyways. Okay. So, as x approaches 1 from the left, what are we using? It's the idea of you could use something like I don't have good answers today. I am on the struggle bus. You guys have days you're on the struggle bus. It's my turn. Big time today. Okay? Just
I thought I was wrong when you wrote the 0. I was like,
okay. So now, here's the deal, guys. We have to think through this. I don't really want to plug this number in, especially if I'm working without a calculator, which I very well could be at this point. So when I plug in 0.9 squared, okay, I'm going to get a value. Now, when I subtract 2 times that number there, how do I want to think about this? And then add 5. What?
it's probably going to be negative. Or it's going to be positive.
I think it's going to be positive. As I said, yeah, it should be positive. Because you're squaring something. And squaring something, generally speaking, is going to be bigger than multiplying it by 2. Okay, and then you're adding 5. So on top, we're approaching some positive value. Agreed? Now, on bottom, when you do 2 times some number that is almost 1, but not quite 1, and you subtract 2, what kind of value are you going to get there? A negative. So what is a positive divided by a negative? Agreed, negative. Now, in this case, this negative on bottom is getting really, really close to what? If it's 2 times a number that's almost 1 minus 2, it's really close to 0. This number on top is a bigger number. So what are we looking for? This is going to end up being negative infinity. Because it's a positive divided by a negative, it's getting very close to infinity there. Okay? Over here, the difference is you're approaching from the right. So if we use, say, 1.01, what does that change? On top, you're still going to have a positive. On bottom, 2 times a number a little bit bigger than 1 minus 2 is also going to be a positive, but it's very close to 0 in the denominator. And when you're dividing by a number in closer to 0 is positive infinity. Okay? And that's our stopping point. Okay, guys. If there's, make sure you finish checking that homework. Make sure you've gone over things. That can be, your homework tonight is to make sure you check over it. You can start looking at the lesson 1-7 homework a little bit. And have a good day.
You're just gonna